Hello, how are you doing? What I'm going to do, I'm going to go over that practice test and number 3 that I've already posted for you with the solution. So I go over those solutions and show you how you can use the application, especially Art of Stats if you want, or how we're going to write it down so that you get the full credit, okay, in the previous last test that we did. For the last quiz, some of you didn't give us any detail of your solution, so that's why you didn't get any point or not get full credit. So we got to be careful for the next test and for the final, okay? Because this part of the statistics is just the inferential one, and you have to tell us how we arrive at the conclusion. So I'm going to show you review that solution that I posted. This test is very important because everything on this test will be given to you on the final. Okay, let me just share that practice test that I've already posted. Okay, so this is, let me share it. Okay, there you are. The concept that we are going to consider are going to be, we give you one question on the distribution of a sample mean, and then the rest of the questions are going to be confidence interval and the test hypothesis. The test hypothesis and the confidence interval are going to be mostly for the mean. But we give you a couple of questions regarding the proportion as well, or the confidence interval of the proportions. Okay, and then we repeat them on the final. They are very easy, but the interesting part is how we're going to set it up, and there is a conclusion that we got to be careful to make sure that get it done and write it down in word form. So the first question is this distribution of a sample mean. Remember, our variable is usually x, and the distribution is probability distribution with the p of x. And when it's a normal distribution, a situation would be given to you, then you find this probability of x. Probability of x to be less than something, greater than something, or in between. Then we are going to have, so in this type of problems, we pick 1% out and we ask the question. But if you are going to be having a sample, a group of people, and if you want to talk about the characteristic of the group, you are not going to talk about the characteristic of 1%. You want to know what's going to be common in the group. So in that case, we use the variable x bar, which is going to be the mean. And then you have p of x bar. So the same type of question of the probability can be done or can be asked about P of X bar. Why we use P of X bar? Because by the central limit theorem, you see this P of X bar is always normal. The sample size must be large, bigger than 30, so that will help us to be able to use the Z-score and the Z-table all the time. Okay, that's why we are going to be very much interested in this one, and we give you one question. So this is question number 1. The characteristic you are going to be interested in is the men's height. It's a normally distributed. We have a mean as usual. This is going to be your mu, okay? This is going to be the mu, and this is going to be a standard deviation, which is what is denoted by the sigma, okay? Then they ask 2 questions. In the first part, they pick 1% out. 1% out. You see, in the first case, if you pick 1%, you're talking about your variable is x. So you ask the question, what is the chance that that person height would be between 67 and 69 inches? So you want to find the probability that x to be between 67 and 69. Easily can be done. You can change it to the z-score and find the area between 2 z values, or we can find it by the application or calculator right away. And I'll show you in a minute, okay? This is the first part. In the second part, you are going to pick a group of 16 people. When you pick the group of the 16, then you are not going to talk about 1%. You are going to talk about the common characteristic of these 16 people. The characteristic that we're going to be interested in is the height, but we are going to talk about the mean height. So the variable is x bar, and you want to find the probability that x bar is between 67 and 69. It's very much like the first part, but the mean would stay the same, but the standard deviation would be different. Sigma would be sigma over radical n. So if you change the sigma, then application of the z-score give you the final answer. Okay, so it's a very easy question and you can't miss it. So I'm going to explain the solutions that I've already posted for you. Then I show you if you want to use ArtStat, when or where in the solution are you going to use it, okay? So let's go back to my notebook and check the solution that I've already posted for you. So it's two cases. There you are. So this is the solution that I've already posted for you. Okay, that's the first part. So what we are going to be interested in the first part, you see, mu is 68. That's a mean, and this is a standard deviation. In the first part of the problem, the sample size is 1. The sample size is 1, and you want to find the probability that x, the variable x, the person, is between 67 and 69. In the second part, your sample size is 16. When the sample size is 16, you cannot talk about the x because you have to find the characteristic of the group. You talk about the average, the mean of the group. So in this case, you want to find the probability that x bar to be between 67 and 69. Okay, so case 1, case 2. In the case 1, the mean and the standard deviation, you see the mean is going to be just 68 that you have, and the sigma is 3. But in the second part, the mean stay the same. That would be 68, but the standard deviation would be different. The standard deviation is going to be the one that you have on the top, okay, 3 over radical n, radical 60, which is going to be 3/4. So you got to be careful when you use this. Otherwise, in both cases, it's just a normal distribution and you'll be able to do it, okay? So we denote this one by x bar. So if you want to do it with steady gap, that's it. You have the normal distribution, 67, 69. They are going to be your x's. Then you change it to the z-score. You know that it's going to be z-score. So the probability in between, you just draw the curve. Okay, draw your curve, and you find z numbers. You can find it from the table or calculator, and then you subtract it. If you subtract it, the probability is going to be 25.86%. Okay, so this is if you want to just do everything without any application. You know that you need only your z-score table, and you find those numbers and you subtract it. I'm going to show you in a minute how we're going to find it from there. You know it, you did it before, but I explain it. Okay, so this is the first part. The first part, when the sample size is 1, you pick 1% out. So if you pick 1% out, the chance is almost 26% that we can find a person whose height is between 67 inches and 69. Now, when we change it to the group, then we have to talk about the X bar. We know that X bar is also normally distributed. So we can do whatever you did here again, but we got to be careful because the mean stays the same. But the standard deviation, the new one, is going to be sigma over radical. So we set up the problem again. So this is the solution that you got. So X bar between 67 and 69. Okay, so the change is going to be in the formula X bar minus mu over sigma over radical n. Sigma over radical n. If you want to do it manually again, you find the X1 and the X. You have the X1 and X2 as before. So Z1 and Z2, the top are going to be the same. You also find the Z values, and then you put them together, and the probability would be almost 82%. So when you pick a group of people, you have more chance. Okay, there are more chance that we can find it. We can find a group of person that the average height of the group are going to be between 67 and 69. But if you pick only 1% out, your chance is lower to be able to find these characteristics. Okay, so it's a very easy case to be able to do it. It's a normal distribution case in both cases, but you got to be careful. The second part, some of the people they miss this. In the second part, you see, in the second part, anytime we go to the X bar from now on, you know that it's not going to be sigma. It's going to be sigma over radical. Okay, if you want to use the ArtStat for this one, you can do it because it's just simply a normal distribution case. Okay, so I'm going to bring this ArtStat just to show you how you are going to use it. Okay, so let me bring it up and then I share it with you. So we go with the ArtStat. Okay, let me share it. So this is going to be our situation with ArtStat. You know it, you use it before. You can use other applications, but ArtStat is much, much easier. Okay, there you are. You go to the web, and you need only normal distribution. So that's a web application. You go down. There is a case with the sampling distribution mean, but that's not going to be helpful. You don't need it. You see, you go to the normal distribution because you want to find the z-score. This is going to be normal distribution. Okay, you dismiss this one. If you have it in your cell phone, that's the case. So we want to find the probability. So we need to give for the case one, part one. In part one, the mean, in both cases, mean was the same. Okay, in the case, the mean is 68. Okay, so that give me so I have the mean of 68. Okay, standard deviation for the first case is equal to 3. That's a standard deviation. And the case that we have type of probability is in between. Okay, in between two numbers, between. The first number, remember the first number is 67 inches. So that gives you 67 inches. And the second number is 69 inches. So that would be 69 inches. So if you put them together, that gives you 26.1. Remember the one that we got was 25.86%. So it's the same thing. Okay, so if you want to do it with ArtStat, but you have to give us this graph. Okay, give us this graph and identify the numbers, or at least you have to give us a notation for the probability. Okay, that you got it. Don't just give us 26.11%. We don't accept that. Just show that this is probability of X to be between 67 and 68 is equal to 26.11%. Or just give us this graph. Okay, so that is the first part. For the second part, you got to be careful. The second part, everything is the same except, except a standard deviation. Remember for the second part, 3 over radical n was 16. So that was 3/4. Standard deviation was the 3/4. 3/4 is 0.75. 0.75. 0.75, check these numbers. These numbers all stay the same. So we want to find the 67 again. Okay, that's a 67. And the 69. So that is 69. There you are. So in the second part, we get 81.76%. And the one that we find it manually was almost the same. We got 64%. Okay, so this is the way we do it. If you want to apply this one, you are welcome to do it, but make sure that change the standard deviation. The mean was 68, and that is point. Okay, that is 0.75, 3/4, 0.75. Oh, be careful. This system, they change the numbers quickly, but it's the one that we did. 67 and 69. So get this information and be accepted. So 82% is the final answer. Okay, so that would be our first question. Okay, so that's first question for this test and for the final, because distribution of a sample mean is a big deal. Okay, it's a big one, and we have to know it, and we are going to use it. So that was the first problem. Okay, so going to the next concept, the next one is confidence interval that we are going to consider. Okay, so I'm going back to the practice test and checking the first confidence interval is very easy to find. You got to be careful because we are going to have different cases for the confidence interval. We may have a confidence interval for the proportion, or you may have a confidence interval for the mean. So be careful on the test. Read it carefully to see which one is it. We give you one from each. You have two over here to practice. There you are. Number 2, find 99% confidence interval for the population mean. So you find out this is a confidence interval for the mean. You know that for this problem, what we have to do, a sample would be given to you. So as you read this one, this is what you have to look for. This, since it's a confidence interval, this 99% would be confidence level. So this would be C, confidence level. Okay, then mean blood plasma volume in the male firefighters. Okay, we're going to check this, measure it. So they give you the mean of the sample. These are sample data, sample information. Sample information starts with the sample size. This is N, which is 45. You identify it quickly. Sample mean, X bar. So the sample mean X bar, you identify it. This is the X bar, which is 37.5. And check to see if the standard deviation is given. To a standard deviation is given, and that standard deviation is going to be 6.7. Okay, now you put them together, the information, and decide how we're going to do it. You know that there is a marginal error that we have to find. So I'm going to go back and explain the situation, which do it manually, because it's very easy to do. But you can use also ArtofStat to do it. But you have to give us the detail of the problem, not write. Okay, so let's go back to my notebooks, explain the solution that I already posted for you. So this is the case. You read the problem carefully. So you realize that it's a confidence interval for the mean. So the mean needs sample data. You have to list the information for the sample data. Even if you want to use the ArtofStat, you have to give us this information. Otherwise, we question you, okay? Because you have to tell us what is the known one and how we're going to find the unknown. So sample data, I start with the sample size, 45 firefighters. Their mean, that was blood plasma, 37.5. Okay, and then a standard deviation, 6.7. This standard deviation is important. In that case, it's a population standard deviation, I put it sigma. When the sample size is big, bigger than 30, this would be sigma. If it's going to be S, they are going to tell you. And then we want to check it against the confidence level of 99%. So we have to find the marginal error, E. So this is the formula for the E, ZC sigma over radical N. Okay, so the sigma is 6.7 is given to you. So you have to use the Z-test. Use the Z-test because the sigma is given. If this sigma is not given to you and this sample size is less than 30, you have to use the T-test. So you got to be careful, don't be confused, and use the proper one. Otherwise, you won't get the point for it. So you have to explain it on the test, that which test are you going to use. If you just give us the final number, we don't accept it. We want to know which test did you use. Did you use the Z-test or did you use the T-test? In this case, it's going to be Z-test. Okay, you need to find a ZC. If you want to do it yourself, we give you a table. And if you check your lecture notes, you have that table for the ZC. And it's a standard. The standard in your book is 1.96. But we may give you something different. I think I've already posted this one too. You see, these are the values for the ZC. I check it. If I haven't posted, I post it again. So this is the Z. This is going to be ZC. So in this case, the C is 99%. So for the 99% is 2.58. Okay, so the ZC, find it from this. Okay, I posted if I haven't, I think I've already posted. So, so for the 99%, your ZC is going to be 2.58. You substitute, simplify, that give you E. So that's a marginal error, 2.6. 2.6, even if you use application ArtStats, you have to locate this one for us, okay? Then your mu, your estimate is between x bar minus E and x bar plus C. You substitute these numbers because the x bar is given to you, 37.5, and you simplify it. You find out that the mu is going to be between, I rounded, between 35 and 40. Remember we talked about the blood plasma of this group of the firefighters, okay? And we predict that the population, okay, population mean of the or all the firefighters, blood plasma must be in this range between 35 and 40. But you have to make a comment. If you don't make a comment, your problem would be meaningless. Okay, so this is the comment. There is 99% chance because this is based on this information that you can make this prediction. So you explain that there is 99% chance that the population mean is between 35 and 40 milligram over kg. Okay, so make a comment at the end to tell us what you mean by these numbers. Okay, mu between 35 and 40. So based on this information, this is what you get. Okay, so this is we usually do it, manually because it's very easy. But if you want to do it with the application, okay, you have to set up the test, sample data, Z should be used. Then you get this E from the numbers from your application, and you have to mention it here. You have to mention this, and then the last part, okay, to get the full grade for this one. I've seen some of you did very nicely. You did all the details in this previous quiz. Okay, even you use these values. You got it from the application, but then you nicely simplify. You nicely explain it. Okay, so what does it mean, the one that you did? So to see how you can do it with the application, so I go to the Art of Stats. Okay, to show you. This is it. I go back to the Art of Stat. I want to make sure I share this one with you. So this is it. Okay, so we are looking for the confidence interval. We have to go down to find the inference. Sorry, this is going to web. Then go down to get the inference for the mean or confidence interval. This is, there you are, confidence interval. Okay, and the significant test. You're going to be stay here for the rest of the problems. So this is for the mean. So for the mean, we are going to have two different cases over here. Okay, when the data are given to you, these are going to be later when we have the t-test. But in this type of the problem that we did have, you better use this option of summary statistic. You see this summary statistic that you have. Then you put the information that you have over here. The information is about the sample. Okay, so you have to put the sample mean. Your sample mean is 37 point. Okay, so that's a sample mean from the information that we have. 37.5. That's sample mean. A sample size. The sample size is 45. Okay, 45. You see this sample, they give you sample standard deviation. There is going to be a difference between the population and because they have two tests. If you use this application on your cell phone, okay, if you have already purchased it, then you have the option here to change it to the population. But if you do it on web, you don't have this option. But since the sample size is bigger than 30, it would be fine because the system would consider this one as a population. So you can use it. Your number would be a little bit different at the end, but both of them happen to be the same, okay? So a standard deviation here is 6.7. 6.7. Okay, then you see, we are going to use confidence interval. If it is going to be test hypothesis, you change it. Look at this. Significant test, you are going to use it when alpha is given to you and you want to do test hypothesis. But confidence interval is the one that we are interested in. Then we have to put the confidence level. Okay, the confidence level is 99%. 99%. Okay, there you are. So this is going to be the information that you get it from here. You see that marginal, that's a standard one, the marginal error that we got over here was 2.6. And this is exactly the same thing. You see, that's E. So if you do this, if you want to do it with the application, you have to take this one out and tell us this. E is equal to the positive negative 2.6, and then you introduce the interval. You see, that's going to be the interval. Interval is between 34.8 and 40. If you round it, that gives you exactly what we have. We have 35 and 40, 35 and 30. Okay? So it would be nice if you take, you can get a screenshot of this one if you want to use it and just paste it on your solution. We accept it right away. Okay, otherwise, you have to give us the marginal error. You have to tell us you use the z-test. Okay, this is the marginal error and this is the interval. And a comment. Okay, you have to make a comment at the end because it doesn't make sense if you just give us this. We don't understand anything. Okay, so be precise. If you just give us this interval right away, you're not going to get much credit for this problem. I saw some of you just give us this. Okay, so important for us is marginal error, E. We identify the E, and then we know that the interval is going to be mu between x bar plus C and x bar minus C. Okay, so you're welcome to use the application, but make sure you are going to be precise. Okay, so that makes it easy for us, and we don't mind. So identify the sample data that we have. Okay, you see this is the way you do it. This is the information that you have to give us, sample data. So the sample data would be sample size because you use them. sample data, sample size, sample mean, standard deviation, and the confidence interval. You drop down into the E, you give us the E 2.6, and then the interval. And at the end, make a comment. Be accepted, and we give you 10 points. Okay, so that is the problem number 2. We have another one. Sometimes you may make, you have to make more comment for us. Okay, that's the point about the next part. So let me just bring it to explain the third problem. Okay, so go back. And so the third problem is again confidence interval. So that's it, the confidence interval that we have. Share it. Let's see what's the difference between these two. Okay, again, we read the problem. It's a number 3. In number 3, the situation that we have is what? We study 40 English composition professors. Okay, so they are teaching English. And the number of the sample size is 40. So we check to see how long does it take them, to grade your paper, if you like. So instead of 40 professors show that they spent on average 12.6 minutes correcting students their paper. Okay, so that's a mean average of time that they spent. So n is equal to the 40, and then x bar is 12.6. So what do you want? Find a 90% confidence interval of the mean time for all composition paper when the sigma is 2.5. So you want to find the confidence interval with the following information: n sample size 40, x bar 12.6, C90, sigma of 2.5. When you find it, there is going to be a number. Okay, it's going to be a range, a minutes. Then a professor stated that he spent an average 30 minutes correcting your paper. What would be your reaction? So you check to see what that range is. And then you compare the 30 minutes. If the 30 minutes is in that interval, so the professor, tell you exactly the time. Otherwise, he may have mistaken or something. You are not going to say that, he was not right. Something, you make up something. I'm just joking. Okay, so let's go back. So this is a situation that you make some kind of judgment, some comment. The point is we want to know if you did understand it, what is going to be the situation, what is significant of that interval that you're going to find. Okay, so sample size 40, X bar 12.6, 90%, sigma 2.5. Quickly, we can do it with the ArtStat, okay? So going back, the information of this problem. Again, this is how you set it up, the problem for us. Make sure you have to give us this information. So the problem is about the mean, sample data, and sample size, X bar 12.6, sigma 2.5, C 90%, marginal error is missing. Again, if you want to do it, 6.5 is given to, so we are going to z-test. This is your formula, ZC sigma over radical n. You have to go to find the confidence critical values for 90%, it's going to be 1.645. You substitute, simplify, your E would be 0.65. Then you set up the formula. So the mu, the time that the professor is spending just grading your paper, is going to be something between 12 minutes. Okay, it's going to be something between 12 minutes and 13 minutes. Okay, 13.5. So you make a comment. The comment is there is a 90% chance because of the level. There is a 90% chance the population mean is going to be between 11.95 and 13.25 minutes. So this would be something for all the professors, all the English professors that grading these papers. They should spend this amount of time to grade your paper. Then the claim that the professor said is 30 minutes. Okay, that's unusual. Okay, because the 30 minutes is not consistent with this range, okay? Sometimes the professor may be tired, okay, to do it. That's why it takes 30 minutes. But you have to make a comment that no, 30 minutes is not in this range. So it would be something unusual, okay? So this problem is the same as the previous one, and you have to make an extra comment for us, okay? So this is the usual comment that you make, and the extra one that you have to compare them together, okay? So again, this is the way you do it, but if you want to do the art stats, you have to identify the information that we given to you, okay, and give us what E did you get, interval, make a comment, okay? I'll go back and double check this one. The limit is a 0.65. So going to the art stat again, finding this so that you know that. So we share it and we find it together. Okay, so that is it's our application. Again, that the web. So we have to go to the confidence interval for the mean. That is it. Confidence interval for the mean. Again, we go for the brief one. Okay, that's it. Summary of the statistics that we have. We have to put the sample size. Sample size is 40, which is good. It's bigger than 30. Okay, and the sample mean. Sample mean 12.6. These are the ones that you already identified for us. Okay, 12.6. And the sigma is 2.5. Okay. Again, if you have a cell phone, they give you the choice for the population, but when the sample size is bigger than 30, the system automatically consider this one to be population. Okay, we want to find the confidence interval, and the level that we check is 90%. So that's a 90%. Okay, that's it. So look at the marginal error. The marginal error that give you is 0.66. We have 0.65. Okay, it's very close. We accept it very close because of this, that the sample, the standard deviation or the population, the changes this, but it's not a big deal because the results going to be almost identical. Okay, so we identify that you get the E positive negative 0.665 from your system, and then the interval. You see, interval is almost the same, 11.9. We got 11.95. And that's a 1326. It's exactly what we have. Okay, so you get your interval if you want to use this one. If you take a screenshot and just paste it in your solution, we accept it, but you have to explain. Remember, you make a comment, there is a 90%, and the comments regarding to the case. Okay, so that is the confidence interval for the mean case one. Okay, the case one is when the sigma is given to you. Okay, so that was problem number, number 3. Let's go back and check the next problem. There's going to be one more case of these. Okay, so I bring the test back here. Okay, so we are going to check what is the problem number 4 is sample size. I did this one because some of you missed it on the previous test. Okay, so we may question you or may not, but let's have it here. Okay, so this is a sample size formula. Because some of you missed the algebra for this. It's easy problem. We don't want to miss it because, it's part of one section of your book. That's number 4. You see, in the previous problem, the situation was created, the sample size was given to you, you find the marginal error. In this problem is the other way around. So you want to somebody order you to do it. You see, you want to go back and study a sample for this case, but you have to know how many people are going to interview. Okay, how large is going to be your sample size? So read it carefully. This problem, and this is it. The economists want to check the mean income for the first year work of the college graduate. We have taking a statistic. We want to know how many do we need to interview. Okay, if we want to be 95% confidence that the sample mean is within 500. You see, this within the 500 means the marginal error of the true mean. Okay, so for this type of problems, you have to look for you see, the only numbers that would be given to you is this one. 3 numbers would be given. This is a 95%. This would be E, within. You see, within means E, the estimate. So this is E. This is 95% and the sigma. So what you have to find for us is N. Okay? So this is the one we call it sample size problem. You have to go back to the E formula, E equal to the ZC, sigma over radical N. You substitute to get this, or we can modify the formula and give you one formula right away. Okay, let me just go back to my notebook. You better keep this formula and just do it right away, really. So, and that's it. This is a situation that we have for this problem. You see, this is the formula. N equal to ZC times sigma over E all squared. Most of you missed it on the previous test, okay? There is a square here. You can use the original formula for the E, cross multiply together, but that's easier. Okay, N equal to the ZC sigma over E all squared. So the information that you have, the sample size is missing. C is 95%. E marginal error is 500, and the sigma is 6,250. Okay, this one, you substitute here. Okay, in the formula, you have to find the ZC, the 95%. You know that the standard critical value, so 1.96. You substitute, simplify it, you get the final answer. And you are going to run this number because this is going to be number of the people, okay? When you have a number of the people, you cannot have any decimal number. We always round it up. We always round it up. So that was 600.2. So you round it up, you get 601. Okay, so this problem is easy. And you can do it with this one right away. Okay, there is a case with that application, but you got to be careful because of the sigma or S. You may get a different answer. But it's easy to do it as it. See, it's just one calculation. And most of you did it right. Okay, so be careful about it. You may see it on this test again. So that's a sample size problem. Okay, now, so what we did so far, we find the confidence interval. In all these problems, population standard deviation, sigma, was given to you. You see, there is going to be a case that this population standard deviation is not going to be given to you. And the sample size is small. So it's in both cases, sample size small means N is less than 30. If N is going to be less than 30, you go back, whatever formula that you have, you see the sigma, you have to change it to the S, sample size. Okay, then you cannot use the Z-test, you are going to use a T-test. And we have to use the T-test and the T-distribution. So I'm going to explain the problem, then I come back and tell you what to do. So you got to be careful. If you use the wrong test, you will lose the point, okay? And you have to tell us which test are going to use, even if you use application, okay? Because that's very important for us. And the reason you focus on the sample size. If they don't give you just directly the population standard deviation, okay? So there you are, number 5. You say random sample of 14. This is the first red flag. 14 is less than 30. So if they don't talk about the sigma directly, this problem must be done by the t-test because the sample size is less than 30. Okay, you cannot use the sigma here. So look at this. This is the number of the phone call that we usually give, in the afternoon, in the evening, when you are relaxing at home, you will get some phone calls that we don't usually answer it. So that's it. They get a sample of 14 of those phone calls. The average of the phone call is 5.2. So we have a sample mean. So the standard, you see, sample standard deviation, not sigma. Sample standard deviation. S is 1.9. So we're not surprised. If that was 14 and that was sigma, that's fine. But since it's a 14, so this is S, that's not unusual. So when the sample size is less than 30, you are going to consider whatever the standard deviation is given to you, you have to consider to be sample. So confidence level of 95%, you want to find the confidence interval. Okay, so the key about this problem is n is equal to the 14, which is less than 30, and the population standard deviation is not given to you, S is given to you. So you have to use this formula. You have to do it by using the t-test for it. Okay, you have to explain it. Let me go back and explain for you. So make sure you know the difference because it's the same for the test hypothesis. In the case of test hypothesis and the confidence interval, if the sample size is less than 30, you have to use the t-test. Look at this one. So problem is about the mean. Sample data, n is equal to 14. Sample mean 5.2. The standard deviation of a sample, S 1.9. Confidence of 95%, and you have to find E. Quickly, they say that the sigma is unknown. And n is less than, this must be less than 30. The cut point is 30. Okay, sigma is unknown and the sample size is less than 30, so t-test can be applied, not the z-test, t-test. You have to tell us, okay, t-test. In the case of the t-test, E is equal to the TCS over radical N. Okay, and then if you want to do it manually, then you have to find the t-test critical value this time. If you want to find it can be done by application, but if you want to find that t-test, okay, you have to use the t-table that I posted for you or calculate. The t-table is very easy. You see, look at this is a t-distribution table. T-distribution table, the difference between the t-distribution and normal distribution is normal distribution, you get one curve for all the cases. But in the case of a t-distribution, because this depends on n, if you change the n, you get the new one. Okay, for each n, you get the new one. So in order to find out which one are going to be looking for, we use degree of freedom. Degree of freedom is n minus 1 in the case of t-distribution. We're going to use more of this when we get through the end of the course. So in order to find the TC, so what you do is this one. N is equal to the 14. Degree of freedom would be 13. So you go to this table and you identify the 13. See, look at this one. This is degree of freedom of 13. This is degree of freedom of 13. Okay, 13. Now, this top one, the third row, this is the confidence level, C, in percent. So this is 50%, 75%, 80%, 85%, 90, 95%. So as you move the 13 here, you're going to match this one with the top value of the 95% for this problem. You see, this is going to be what you have over here. I can find you see, this is what you have. This is 13. Okay, this is 13 and the 95%. So the connection between these two, you see the number over here, that's a 95% this one. So we get 2.160. Okay, degree of freedom 13 and the 95%. So the TC is going to be 2.16. That's everything, and only thing you need. That's it. So degree of freedom of the 13, you move on. You compare it with the 95% on the top. So that gives 2.16. So that's a TC. TC is 2.16. You substitute in the E formula. That's a TCS over radical N. You simplify it, mu between 4.1 and 6.3. Okay, this is if you want to do it without any application. It's very easy to identify. Oh, TI-83, 84, all of them would give you this number right away. So this is the number of the phone call. Okay, so we have to run that between 4 and 6, and you have to make a comment. The comment is, again, there is a 95% chance that population mean is going to be between 4 and 6 phone calls. So this means if you consider for all, based on this information, you may consider this one for everybody. On average, every evening, you may get between 4 and 6, phone calls. Okay, so that's going to be case one for the, for the t-test. So you have to identify that you use the t-test because the n is small, and to get these numbers. Okay, but that application would give you this result right away. So let me show you. Again, if you want to do it in this form, tell us that sample size information. You have to tell us that the n is sigma is not given to you, so you have to use the t-test. You have to give us this information. Then either you continue to get it, or you go to the ArtStats and get these numbers. Okay, the ArtStat one is going to be the same place that we went on for the other ones. Remember, you have between 4 and 6. Let's see if we get the same one with the application. Okay. So again, ArtStat. Go to the same place, confidence interval. That's it, confidence interval. Again, we are in the briefcase. Summary. So give us the sample size. Sample size was small, 14. Okay, sample size of 14. Sample mean of 5.2. Okay, that's a 5.2. And then we have S of 1.9. That is going to be 1.9. Okay, that's a type of, we are still in the confidence interval. Ignore about this one and just put the confidence level of 95%, in fact. Okay, that's it. So again, you can give us a screenshot of this, or the information that we need is E marginal error is 1.09, which is almost the same thing because we have 1.1. We have 1.1. If you run this one, that gives you 1.1. And the interval, look at the interval, between 4 and 6. So there is a chance that you get it. That's exactly the same number, 4.1 and the 6.3 that you get. Okay? So, the system would read it by itself, that you use the t-test or the z-test. But you have to tell us which test did you use, okay? You have to tell us which tests are going to be valid for this one. Okay, that's a t-test in this case because the sample size is less. identify the marginal error and the interval, and make a comment, and you're done. Okay? So this is case one. There are going to be two different cases for the t-distribution. The t is more popular because we use it for the small sample. Okay, what's going to be case two? Be prepared for both of them. You see, case two, since the sample size is usually small, in the case of the t-distribution, they give it the actual numbers, okay, actual data values. So you are going to be given a list of the, for example, 14 numbers. If that would be given to you, you have a couple of more things to do. Because in that case, you have to find the X bar yourself. You have to find the S yourself. Okay, but the application will do it for you, or a calculator. So you have to set up these first, and then you'll be able to do it. Okay, and that's very much more popular. And we have, let me just bring one that we have. We give you one, so that you know how you are going to handle, handling this part. So let's go back to the question again, and that will be our next question. So I put two for you to practice, but we give you only one of them. Again, on this and on the final. So let me share it. This is the very popular one because we are interested, to connect to the everyday life problem. So we are interested to find the actual numbers. Look at this one, number 6. Number 6, what is this? This is, we check the salary of the substitute teachers. Okay, you can be a substitute teachers for the schools, and they usually give you something around $60 to $65. Depends on depends on which school district are going to be. Okay, so this is it. We have a group. We daily salary. We check the salary of 8 local schools, and this is the time. Okay, the salary we find out is going to be 60. These are the numbers, actual number. For each school, we have 60, 56, 67, 55, etc. So what we'd like to do is we'd like to find a 90% confidence interval. Based on this information of the sample, you would like to make a prediction. Your prediction is going to be for all district. Okay, this means we only, for example, Carlsbad or Oceanside. So you want to make a prediction for all the region, if you like. So the difference between this problem and the previous one is you have 8 schools, 8 numbers only. So you have to use the t-test because the sample size is very small. But in order to do it, you have to find the mean and the standard deviation yourself. Okay, and then set up the test. So this can be done by that application much easier because we have a case that we can put the numbers in. So let me just show you the solution of the manual one, and then in the application. But for this one, the application would be, you can save some times to do that, but it's not a big deal. You can do it as well. Okay, so this is if you want to do it as is. So the information that we need, it's about the mean. So we need a sample size, which is 8. We need a sample mean, which we don't have it. We need the sample standard deviation because it's very small. Okay, we don't have it. So we have only the confidence level, and we are interested in marginal error. So with these numbers, you have to find the X bar and S. You know that you drop it into the system quickly that give you the mean and the standard deviation. Just to refer to the formula that we usually have. These are the X's. You have to find the X squared. So the sum of X's is 416. I divided by 8, the number, so that give me the X bar 59. And the formula for the standard deviation, sigma x squared, sigma x all squared over n, that give you 5.2. These are stats give you these numbers right away. But If you want to do it yourself, you have no, the information is completed. So we have the sample size of 8, X bar of 59, S of 5.2, C of 90%. We are interested in marginal error. We have to check the test. Which tests are going to use? N equal to the 8 is less than 30. So you have to use the t-test. Again, even if you want to use the application, you have to tell us, which test did you use? Did you use the z-test or did you use the t-test? Since the sample size is less than 30, we have to use the t-test. If you want to do it yourself, you have to find the TC. Again, N is equal to the 8. Degree of freedom of 7, you see. It's the way you have to find the TC. Degree for freedom of 7. This is 7. This is 7 and the 90%. You see, 7, you just keep going to get to the 90% on the top. So the 90% is 1, 2, 3, 4, 5, the fifth one. So that's 7, 1, 2, 3, 4, 5. So 1.895. Okay, so that give you your TC. Again, degree of freedom 8 minus 1, which is 7. You just match it with the 90%, so that gives 1.895. So that would give us the TC, 1.895. So we just substitute, simplify to get a marginal error of 3.48, and X bar minus C, X bar plus E. So eventually we get something like between 55.52 and 62.48. Okay, so almost 56 and 63, if you like. Okay, remember that was the dollars a month salary of a substitute teacher. So you have to make a comment that there is a 90% chance that the population mean is going to be between the salary of all the teachers, all the substitute teachers are going to be between $56 and the $63. Okay, so this takes a little bit more time because you have to set up those information yourself and make sure you use the t-test. Let's go to the application to see how we're going to do the application type. Okay, so let me just go back to that application, and we have the web. So that would be the web. Now, if you want to do it by the application, you see that summary that we use. It's not going to be useful here. You have to go to the, okay, to the full version that we have. Okay, you can say my own. You see, this is going to be your own. For your own, you have to put these numbers that you have. Okay, so the number that we have are the following. Okay, 60. We put a distance in between, 56. Okay, 60, 55, 70. Okay, 55, 60, 55. Okay, that's all you have. So as you can see, you already got the sample mean of 58.88. This is the one that I call it 59. And I have the sample standard deviation of 5.08. I have 5.2, which is close. Okay, I just check to see, make sure I have 8 numbers here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so we already got that's it. We need the confidence interval. Just make sure that we get the confidence level was 90%. Okay, 90%. Okay, you don't need to do anything else because it's already done. So as you can see, the interval would be 55.47, which is close to the 56. We have 55.52, and that's a 62.48. So almost exactly the same interval. But make sure you make a comment, okay? So it's very easy. to do it with this application, save you time, and this is the everyday life. This is the real one. Real one, you may have a bunch of numbers, so the numbers can be less than 30. So be careful for two cases that we have. If you want to use this one, again, you have to write down these numbers for us. You have to write what is the sample mean, sample standard deviation, marginal error, and you mentioned that you use the t-test, and this is the interval, and of course you make a comment. Okay, so this is two different type of the confidence interval. The confidence interval for the population mean. The one with the z-test and the one with the t-test. Okay, we give one from each, and we go over it. Okay, so that would end up the confidence interval for the mean. So I'm going to leave it here. Okay, take a break and come back and do the test hypothesis, and we didn't do the proportion. Okay, so I don't want to be too long. So we take a break and we come back and we do the rest. Okay, see you then. Bye.